Hi, welcome. In this little video, we're going to talk about how to multiply matrices. But let me first say that you can only multiply matrices if, like, let's say we had a two. Sorry, let's go. Okay, we have a 2 by 3 matrix, and we were multiplying that by a by a 3 by 4 matrix. And that would look like the 2 by 3 matrix would look like this. Let's say A, B, C, D, E, F. So I'm just using variables to represent the elements within that matrix. It has 1, 2 rows and 1, 2, 3 columns. These are the rows and these are the columns. And then let's say we were multiplying that by a 3 by 4 matrix. That one would look like something like, let's see, pick up where we left off here. E, F, G, H, I, J, K, L, M, N, O, P, Q, R. And so again, this one has 1, 2, 3 rows and 1, 2, 3, 4 columns. And so this is the number of rows and this is the number of columns. This is the number of rows and this is the number of columns. And these two matrices could be multiplied, but only because the number of columns in the first matrix matches the number of rows in the second. So if I were to switch the order and try to multiply them, if I were to try to take the 3 by 4 matrix and try to multiply it by the 2 by 3 matrix, I could no longer do it because 4 does not equal 2. So the number of columns in the first has to be equal to the number of rows in the second. And when you're done, when we were finished with this multiplication, we would have a 2 by 4 matrix. The result would be a 2 by 4 matrix with 2 rows and 4 columns. And so that's kind of how this works. So let's go back over here. We're multiply A times B, and this one has A is a 2 by 3 matrix, and B is a 3 by 1 matrix. And so we are going to be able to do that because that number of columns matches that number of rows. And when we're finished, we're going to have a 2 by 1 matrix. So this is kind of what that looks like. Let's call this row 1 and row 2, and let's call this column 1. There's only one column, but it has 3 elements in it. And so what we're going to do for our matrix multiplication, A times B, we're going to set out a really big matrix here so we can write everything down here. We take all of the elements in row 1, 1, -2, and 3, and we multiply them by all the elements in column 1. And so we're going to add that up. We're going to take 1 times 7 plus -2 times -2 times 8. And then we're going to add that to 3 times 9. Let's add a little color to this so it kind of makes sense here. We're going to take let's say these rows here. 1 is this 1 right here. This -2 is this -2 right there. And this 3 is this 3 right here. And then let's use light blue. So this 7 is this 7. This 8 is this 8. And this 9 is this 9. And then we're going to do the same thing for the second row. So for row 2, let's highlight that also. 4, 5, and -6. So we're going to put 4. 5 is going to go there, and -6 is going to go there. So this will be 4 times 7, and this will be added to 5 times 8, and this will be -6 times times 9. And so these numbers right here are still the same. We've got 7, 8, and 9. And now we'll just work through and crunch those numbers. 1 times, probably made that a little bit too big. Let's put this, just bring that down, tighten that up. So 1 times 7 is 7. -2 times 8 would be negative 16. And then I got plus, and 3 times 9 would be 27. And then 4 times 7 is 28. Plus 5 times 8, that would be plus 40. And then -6 times 9 would be -54. We're almost there. Now we just got to take those numbers, continue to evaluate them. 7 minus 16 would be -9. -9 plus 27. And then 28 plus 40 would be 68 minus 54. And then one step more, -9 plus 27 would give us 18. And 68 minus 54 would be 14. And so 18, 14, which is how we got that answer.